site for an atmosphere site for GLOBE. So today we're going to talk about, let's see, I'll share my screen in theory. All right, so here we go. So we're going to talk about hydrology observations. And, oh, before we do that though, I wanted to, just introduce the Mission Earth group and how it works. So we have a collaboration between the University of Toledo, Boston University, WestEd, / UC Berkeley, Tennessee State, and NASA Langley. Well, I'd say NASA in general probably. And our goal is to fuse GLOBE and NASA assets to change STEM education. So this is the group that's going to be presenting or talking today. You have myself, Janet, she's going to be moderating. Sara Mierzwiak will help out with some videos and showing you some hydrology protocols. And then Melody Tsapranis is a Toledo Public School teacher. Okay, now I'm blanking on your school, Melody. I think it's Navarre.
Got it. Okay.
And we'll see some video of her kids. And then we have Laura Shetter. We showed her kids 2 weeks ago, so she's going to be on a little bit later. And then Kristen Weaver, we're lucky and glad to have her from NASA Goddard today. And this is kind of our breakdown is going to be, I'm going to talk about Lake Erie and water quality, harmful algal blooms. Then we'll go into the hydrology protocols, including site setup. Melody's going to be our teacher feature, then with Laura Shetter as well. And we're going to have our NASA nugget on the global precipitation measurement mission. I put program there, but it's mission. And that's by Kristen. And we'll have some questions at the end, questions and answers. So why are we doing this? One of the reasons is we want students to do projects. And so we have some students here. We have one of Connie's students. Of course, I forgot her name, but that's all right. She did a nice water quality project, and that's one of the projects that Connie tends to have her kids do, are water quality in the Detroit area. So we want kids to do projects, research projects, taking GLOBE observations, posing questions, getting data off the GLOBE website if they need to, comparing the data, looking at the data, analyzing it, getting results, and then drawing conclusions, and then presenting their projects somewhere. And there's obviously there's lots of opportunities to present, for the students to present their GLOBE projects. There's the International Virtual Science Fair, and I think we will have deadlines somewhere maybe March timeframe. So prepare your kids for that. Last year, they gave out awards paying funding for kids to go to the GLOBE annual meeting. There's also the regional science fairs in the United States, and they'll be in the spring 2017. And the one in the Midwest will be at Purdue University in May. Of course, I forgot the date of that as well. I probably should rehearse or something to get my facts straight. All right, so I was looking at messing up and looking at the chat room. And then there's the GLOBE annual meeting, which is an excellent opportunity for kids to learn, present their research, and also be exposed to kids and scientists and educators from all over the world. I mean, I can't stress it as how much these annual meetings are impactful on kids. So if you can get your kids to the annual meeting this year, that's a win for everybody. I got both of my kids to go this year. Usually Timmy, my youngest, has gone in the past, but I got Robbie to go as well, and I think they really enjoyed their time, learned a lot. Robbie is in the middle picture, and he's presenting with kids from Thailand, Taiwan, and Mongolia. Oh, and this year, go back to that, the meeting may be in Connecticut. We're not sure yet exactly where it's going to be. There was just maybe a rumor, so Don't tell anybody that, oh, Kevin said it's in Connecticut. So we don't know yet, but just prepare to go somewhere, probably in the United States. Now I'm going to switch gears and talk about the water crisis. This is one of the big things that happened in Toledo. In 2014, there was a large algae bloom. The algae bloom got into the water intake, and that's the picture on the left. That's the water intake in Lake Erie. It looks like a building, but that's what, there's a big pipe in the bottom that sucks in all the water that is then used for drinking water. And it caused a big crisis because people they were advised not to drink the water. There was microcystin in the water. So microcystin is a toxin. It's a neurotoxin. So it could affect your brain, but also is bad for your liver and kidneys. Yes. All right. So everybody could mute when they get on. That'd be good. So here's some pictures of the harmful algal bloom from satellite imagery. This is a MODIS image of the algae, and it actually looks green because it is a plant. But it's not only Lake Erie that has these algae blooms. There's algae blooms all over the world. Lake Taihu, I think it's pronounced, in China, has had some very bad algae blooms, and Lake Winnipeg in Canada. And also they happen in the ocean, so the Baltic Sea. So why are these occurring? So here's some data from Heidelberg College, or Heidelberg University, which is in Tiffin, Ohio. It shows the discharge in blue of the Maumee River, and then compared to the concentration of phosphorus in the water. And I'll ask you, everybody, what do you notice about this image? So you can put it in the chat if you want. Okay. What do you see in this image? The relationship between phosphorus and discharge. I'm asking for group participation here. So no one wants to type in their guess? Oh, here they come. Okay. Okay, so the concentration of phosphorus increases with discharge. Okay, good. Looks like a direct relationship. All right, yep. Pretty close correlation. And that's exactly right. So when there's more runoff, there's more phosphorus going into Lake Erie from the Maumee River. And later today, when we talk, when Kristen talks about the GPM Global Precipitation Measurement Mission, she's going to talk about how it looks at precipitation. And obviously, you can see there's a direct correlation between precipitation and water quality in this case. All right. NOAA puts out a harmful algal bloom bulletin, and you can sign up for it. So if you're interested, Google NOAA experimental Lake Erie HAB bulletin, something like that, and it'll come up. You can subscribe through your email and get this bulletin once a week. So throughout the summer, you'll see the algae bloom grow in Lake Erie. They use satellite imagery to do this. Here's an image from August 5th, 2015. Red is high algae, and you can see the whole western basin of Lake Erie was covered with a lot of algae. So 2015 had a very, very large algae bloom, mostly because it rained a lot. I had lots of problems with water coming in my basement. Ended up redoing the drainage around my house. This shows the phosphorus loading to Lake Erie by year, and the green is 2011. and it has months on the lower x-axis. You can see how 2011 had a lot of phosphorus going to Lake Erie, and that was a year with a large algae bloom. 2012 had very little. There was a drought that year, so there was not much algae, or not much phosphorus going into Lake Erie. 2015, as I mentioned, was very high again, and actually went above 2011. And then 2016 was pretty low, and they showed, now this was a prediction, I was trying to find things on the internet, the likely concentration and the possible, and it actually stayed low on the low end of this because it didn't rain a lot. So we can pretty much predict the algae bloom size by the accumulated rainfall and accumulated phosphorus loading. Now I want to show you what the University of Toledo has been doing in response to this. Of course, the University of Toledo is key. We're right near Lake Erie, and we have a buoy that we put out near the mouth of the Maumee River. This is an early warning buoy for when the algae starts to form. The university got a new research vessel, which is great, and you see some Tom Bridgman, who's our algae expert, here in the lower picture with some students taking observations. And then my work has to do with the land, and I've looked at how tile drains affect nutrient runoff. So tile drains are these are tile drains. Basically, they're plastic tubes the farmers put under the ground to drain the soil. And farmers have been putting more and more of these tile drains in. The reason they do it, this area was a black swamp. It was called the Great Black Swamp. Actually, an aside, Janet is a member of the Great Black Swamp Blues Society. So that's just an aside there. But it was a swamp. So the area's been drained, and these tiles drain the ground, and the farmers get much higher yields with the water drained. Here's what they look like when they're put in. They just kind of make a trench and put the tile in, the plastic in. And what I've found was that we can see them from aerial photographs and satellite imagery. And you can see in this picture, the dry areas are, the lighter are dry above the tiles, and the dark is moist. So you can pick out where the tiles are. Okay, I've said enough. And before, I think now we're going to switch it over to Sara and Melody.
All right, I'm working on sharing my screen here. So did you want me to cover this setting up your site first and then the video, or the video first?
Oh, that sounds good. It's setting up your site.
Okay. So this is similar to what we covered with setting up your atmosphere site. But in this case, so you'll recall if you were attended webinar number 1, that I've used Google Earth as an example of a geospatial technology that you could utilize to introduce your students to your school grounds and kind of search for sites to set up. In this case, I'm using Google Maps just to change it up a little bit. And I'll talk about collecting the field data needed to set up your site, and then entering that data on the GLOBE website to actually establish your Hydrosphere site. So this is from the last presentation, just to review very quickly, just to re-emphasize that under the umbrella of your organization, you can have multiple sites. So last time we talked about atmosphere, this time we'll talk about Hydrosphere. Perhaps in the future we'll talk about some of the other ones. I also want to remind you, if you haven't done so already, that you should probably create a student account at this time, so that you can, in the future, when your students start collecting data, that they can log in using that student account. And you can find that under your profile on your page in GLOBE after you sign into GLOBE, and then you can create that. And again, if you need help, the GLOBE support team is great. So a reminder again that starting with geospatial technologies really is a good way to get your students thinking spatially. Ask them, what direction is north? Have them point. in the direction of north and use one of these mapping programs, whether it be Google Earth, Maps, Bing Maps, or anything else, and orient everyone before you go outside. So I know there's a lot of text here, but I tried to just summarize everything here that I will cover. Basically, you're going to open up Maps, Google Maps. You're going to zoom in and check out your school grounds. And I added a few slides in here about this part. We highly recommend, and this is something that we learned from visiting Laura Shutter's school, that it's really a good idea to do a review or a quick introductory lesson on latitude and longitude. And I found a cool, fun video that you can use to do that. And I'll share that with you. And then within Google Maps and in the classroom, see if you have a stream, pond, lake, or other water body on or near your school grounds, and go ahead and zoom into it. And once you see an area that you'll be most likely to actually access that water body, right-click on that position, select what's here, and immediately your latitude and longitude of the location shows up. And that's something obviously that you need for your GLOBE site definition sheet. Then once you're outside, confirm that data with your students using a GPS. And this time I've added some screenshots because I thought it would be helpful of the GLOBE protocols for the GPS field guide and the GPS investigation data sheet. So, and then as far as the data that you'll actually collect for your hydrosphere site, it depends on the type of hydrosphere site that you have, whether it's a stream, then you'd want the width. If it's a pond or lake, you also want the depth, and you want the substrate, things like that. So what is a good GLOBE Hydrosphere Study Site? Well, first of all, it's got to be accessible, right? It's got to be safe, free of too many hazards. Hopefully you have something on your school grounds. However, we have teachers like Melody who takes her students far away from the school grounds and accesses so let's say a public park hydro site. So if there is something nearby that's on private land, obviously get some permission first. And if you are sampling a stream, you want to try to sample in the riffle area as opposed to a stagnant area. And all of this obviously is with the goal of connecting your local water issues to global water issues for your students. So building that local to global connection. So in this example, what I did was virtually return to Laura Shutter's school at Toledo Public Schools Natural Science Technology Center. And so within Google Maps, maps.google.com, I just entered in the address. And you can see here what pops up is the road view and street view as well, which is pretty cool. And down here is where you would switch between satellite and road view. And the first thing you'd want to do is just ask your students, well, where are the water bodies? And in this case, we have this nice long stream, right, running through their school's campus. So if you start to zoom in to that area and switch it to satellite view, you can start to get your students oriented, ask them, you know, where's the door that you walk in? Where are the buses parked? Which direction is north? And if you right click on that, this is what it looks like. It says, what's here? And then right then and there, your latitude and longitude pop up, which are in decimal degrees, which is what is needed for your site definition sheet. And then I also suggest that you go ahead and zoom way out from the school grounds, especially if you have a stream, so you can see where does that stream flow? What direction is it flowing in? Use the rule of V's, right, for direction of flow. So, and we are also looking to see if it had a name. We talked to the people who worked at the school, even those who had worked there for a long time. No one really knew the name of the stream going through the campus. So for purposes of your GLOBE site definition sheet, you could call it something like tributary to, in this case, the Ottawa River. So here's a kind of cool video I found for reviewing latitude and longitude. This guy, it's geared towards kids, and this guy literally uses a chainsaw to chop through a globe to show lines of longitude, and then he does the same thing to show lines of latitude. He gives a nice explanation. It's 6 minutes long. You can find it through this link here. I won't play it for you, but I searched YouTube for a number of different videos and thought this one was kind of fun and informative. So if you also want to get into the more detailed academic explanations of latitude and longitude, of course, NASA has some great sites for that. They also have something through their My NASA Data website, which is their latitude and longitude finder. And it's a great way to do the same thing that I just showed you with Google Maps and kind of zoom in and from a mapping program, just find your latitude and longitude. So now you're ready to go outside, right? So you want to head outside, and this, I always want to add things in about safety hazards. I think this is due to my training as a project manager on many sites for many years. We always did safety meetings before any work was done on site, and I still like to implement that. So ask your students, what are the hazards that they see around them before they start doing anything? Where's the first aid kit? What's your school's procedures for dealing with any incidents? Just very quickly, it only takes a couple minutes. That can make a big difference in if something were to happen. So you want to have them supplied with the real measuring tape. And I forgot to include it in here too, but a meter stick actually works great for checking the depth of your water body. A clipboard with your site definition sheet, GPS unit, and printed copies of the field guide and the GPS investigation data sheet. And before you head out, you should also check all of your GPS units to make sure that they're in decimal degrees for latitude and longitude, not degrees, minutes, and seconds. And if you have students who are maybe a little older, more capable, maybe have them actually do this themselves, get into the settings of the GPS unit, and they start to familiarize themselves with the GPS. So these next few slides will go very quickly. They're just screenshots of the GPS protocol field guide. And I won't read all this to you, but it gives you a nice detailed set of instructions here on how to operate your GPS and the things that you should look for. Wait till you have at least 4 satellites, 2D or 3D status icons, and then start to record that information on your data sheet. And then here's where, I know this looks like you would record this from multiple locations, but this is the GPS investigation data sheet and the GPS protocol through GLOBE are set up to try to maximize the accuracy of your GPS reading. So you want to stay in the same place, wait at least a minute, or wait at least 1 minute between recording each observation and have them take averages. And you're also looking here at the number of satellites that you're seeing as well. So that's a neat kind of spin-off discussion there of satellites in the sky. So back to the Toledo Natural Science Technology Center, you'll recall from last time that we figured that we could have 3 different GLOBE sites there, study sites, one with two atmosphere sites, surface temperature sites, asphalt, grassy field, and then here's our stream. And then just a couple screenshots of the students. So they were collecting their GPS coordinates, writing the information down on the sheet with a clipboard. And then measuring the width of the stream using the real measuring tape. Laura was lucky enough to have a full set of wader boots for all of her students. So maybe there's a way you can get your kids a set of these if you do have a water body on your school grounds. And then use, ideally along this same transect, use a meter stick to check your depth. So here's your site definition sheet and everything that you would fill out here. So take those averages that you found before, your latitude and your longitude, and enter them there, your elevation. Check your GPS and put also, which is also on the GPS data sheet, the type of GPS unit that you have. And you'll select hydrology site. And again, just to review, the site definition sheet covers all different kinds of GLOBE study sites, and they're separated by these bold lines. So you would go just here to your hydrology area. And this is what it looks like. So you would choose what kind of water body. Most times will probably be freshwater, unless you live along the coast. So for a stream, you just check that and put your width of the moving water there. If you have a pond or a lake, it also wants you to definitely record the average depth of standing water. So also ask, can you see the bottom? What does it look like? Check all of these that are appropriate. Maybe circle the most prevalent one if there's vegetation. The bedrock, I have a little note on the next slide about how to help you figure out what your bedrock may be. And then all the different freshwater habitats, check those. And then again, this bold line here signifies the end of the hydrology section. And that on the site definition sheet gets into the land cover site. So that's all you have to fill out. So if you're not sure of what your bedrock is, your geology in your area, there's a great site, and I linked it here through the USGS, and you can just click on your state and pull up a geologic map. There's a key that you have to bring up, and you can see from the color what kind of bedrock that you have. So you take that information, log into your GLOBE site, and select this data entry desktop forms and add that site. And here's your areas here where you put in your site names. You could give it a name, your latitude, your longitude, elevation. And so once you have this all set up, obviously, then that's when your site is ready to roll. And you can have your students log in with their student account and enter their data. So just very quickly, so for hydrosphere investigations, it's recommended through GLOBE that you do most of these on a weekly basis. It's not to say that you couldn't do them more often. Water transparency, temperature, DO, all of the different hydrology protocols, pretty much basically a weekly activity. Semi-annually then would also be freshwater macroinvertebrates. And again, what I'm talking about here is this once per site GPS measurement protocol, site selection. So if you want additional information, again, check out the appendix to the implementation guide. Page 21 has a lot of information on how to set up these sites. And for even more information, go to your GLOBE Teachers web guide. So that's all I have for now. And hopefully that makes some sense. Do we have any questions?
I have a question real quick. I was wondering how the GLOBE Observer app is that pretty accurate in the latitude and longitude if we were using that as well?
Should be. Dr. C's on mute. Janet, can you unmute Dr. C?
That's fine. Sorry, I couldn't understand you. So yeah, my understanding is that your cell phone's not quite as accurate as the GPS units, but they're pretty good. And from what I've seen, more or less they're accurate. I did take one observation and ended up inside a building on the map. Of course, I wasn't in the building, right? So the GPS was just off.
So the GLOBE Observer app, is that reliable?
Yeah, I would say so, more or less. I mean, and that's for the clouds right now only.
Yeah, but it does give you your latitude and longitude, and I was just curious about that.
Yeah, like I said, generally your cell phone has a little bit more error than the GPS units.
And that's what I was going to add, is that I think it's just going to be, I think there may be some variability between cell phones too. So presumably, I would assume, I don't actually know this, that newer cell phones are going to have more accurate numbers, but I don't know if anyone's looked at it.
Yeah, there is also these things called datums, which we get into in our master's and PhD programs at the university, where you have to choose your datum on the GPS unit. So if you have different datums, it produces different locations. A little bit of error associated with those. So if you have different GPS units with different datums in it, then you'll be in different locations and have different amount of error. And it's a little, that's confusing.
What do we do with the hydrosphere site definition if you're using the Maumee River for depth and width?
Oh,
yeah.
Excellent question. Well, you could, if you download Google Earth, and you have that, you could estimate the width using the drawing tools like we talked about last time. That's one way you could try to approach it. There's also USGS data on the Maumee River that you could access. I'm not sure if NOAA also has some of that information. And right there where you are as well, you've got the shipping channel there. And I think the depth, they dredge that to about 30 feet. So that's a artificial, human-made depth right there for the river.
I know I've used the USGS Topo Maps app on my phone, and it'll say the depth of the river. And then again, they do take that to a certain depth when they're dredging it, so it'll show that.
Mm-hmm.
Topo Maps.
Yeah. Now remember on the site definition sheet for a stream or a river, I don't think it necessarily requires that you enter the depth. That's more for, ponds or lakes. But you can add that as additional information in the comment section, which is interesting to talk about with your students anyhow, especially for a large river site like yours, Debbie.
So Sarah, we probably should move on to the videos.
Yeah, sure. Okay.
So the actual taking of observations.
Yep. Let me go back to sharing screen.
Now, one thing I should mention is the reason we're doing this webinar today is that the Student Watershed Watch in the Toledo area is coming up. Okay, now I forgot the date. I'm just like forgetting everything today.
October 5th.
October 5th, there you go. Thanks. So, just as kind of a review for everybody who's going to participate in the Student Watershed Watch.
Okay, so we're still learning to use this video making software as well as playing around with different mics. So the video might be a little grainy and the mic might sound a little fuzzy at times, but we'll keep on improving on that.
Hi, I'm Sara Mierzwiak. I'm with the University of Toledo and Globe Mission Earth, and I'm here at Navarre Elementary School today. And
I'm Melody Tsapranis. I'm a 7th and 8th grade science teacher, and we do GLOBE in the classroom. And I have two of my 8th grade students going to show us how to practice taking water quality measurements in the classroom. We have Aileen and Precious are going to help us today, show us the proper techniques for doing dissolved oxygen with the Chemets kit 7512, with the Chemets nitrate kit 6909D, the Chemets phosphate kit K8510, and the Hatch pH kit. In addition to the kits, we do have some probes, some vernier probes, which we will do water temperature with, and then we will also take water temperature with a regular water thermometer that you use out in the field. So we're going to get started.
Mrs. Tsapranis now has the students follow the directions from each of the kits and begin performing the following tests: nitrates, dissolved oxygen, phosphates, pH, and temperature. She has a lot of experience using these kits and has figured out how to time them so that while one is processing, the students begin another kit. For example, the nitrates vial has to sit for a few minutes while the chemicals react, so the students are then free to start using another kit. She makes this easier for the students by printing off copies of the instructions from each kit, as you can see in this next clip.
One thing I did that's helpful to students is I went online to each of the Chemets or the Hatch companies, and I printed off the directions very large for the students. It's very helpful. You can put them at eye level. We're going to have them in front of us today. Make sure you have timers with you because you do have to keep track of the time. We use an empty plastic bottle to keep our vials in because they will have sharp points. So we use that for our sharps container. Distilled water.
The students continue following the directions using water that Mrs. Tsapranis brought back with her from her trip to Greece this summer. She emphasized to the students that certain tests, such as dissolved oxygen, must be performed very quickly following sample collection, and as such, the results in this exercise are not usable. They're just for learning purposes only before the students go to an actual hydrology study site for GLOBE. Note also that they put on their safety gear, including goggles, gloves, and lab aprons. Some of the kits involve breaking the ends off of small vials of glass, and these pose a safety hazard. To avoid accidents during this process, Mrs. Tsapranis has students hold 2 fingers over the container to stabilize the vial before applying pressure to break the tip. The students then compare the color of the sample vial to the indicated vials with the kit to determine their final concentrations.
It's right in between 4 and 5.
So what do you think the reading is?
Almost 5.
So you think it's closer to 5? Okay.
So what was our dissolved oxygen? Between 4 and 5. So like 4.5, which isn't unusual since it's been bottled up for a while. But we would want to have it probably higher if we got it fresh out of the water. We're going to take our vial, our ampule, and put it into our sharps container. Did a nice patience on that. And here is our nitrate comparator. And what do you think, Aileen? Where do you think it's going to match up? 0. Lucky, let's leave it there for a minute. They'll show the camera. Luckily, there was no nitrates detectable in this water after sitting around for a while. I think that wraps up doing temperature, dissolved oxygen, phosphates, nitrates, and pH. We make sure we record our results on the GLOBE data sheet, and you would take these measurements 3 different times to make sure that you have accurate results. And that's pretty good. We don't do salinity here at the Great Lakes, but that would be a test if you're by the seashore. So yeah.
I just want to point out that you can see that these tests are quite complicated. There's a lot of steps involved. There's a lot of coordination, and it's really a good idea to do like Melody's doing in practice in the classroom before you actually go out into the field.
And I will add also, it's not so complicated. That 6th, 7th, and 8th graders can't follow the directions. It's just practice. That when you're out in the field, they would have a mentor, somebody to guide them through it, but they do the steps by themselves.
Yeah.
Thank you. Say bye, Globe.
Yeah.
Bye, Globe.
Okay, so one thing I want to point out really quickly also, and you might be able to see it here, another neat thing that Melody figured out to do, especially when you're juggling multiple kits like this. So she just takes a white paper towel, and when those vials have to sit and process, has the students just write, is it nitrates, is it dissolved oxygen, and just lay it on that towel. That way you don't get them mixed up, because some of the indicator ones have the same color, and that could be easy to do. So hopefully that was informative, and not sure if there's any questions on that.
Great editing.
Oh,
That was great, Melody. Thank you, and thanks, Sarah. I posted a link to our phosphorus data entry on SurveyMonkey. So if you take phosphorus observations, you can enter it on SurveyMonkey with that link, because the GLOBE website does not have phosphorus data entry. It's not one of the protocols, but I know it's a very important observation for us. All right, is there any questions for Melody or Sarah at this time? Maybe take a question or two.
Would you like me to unmute everyone?
No, I think maybe
In the chat room?
type in the chat room. Yeah, it might be good. And then we'll get ready for Kristen to talk about GPM. Let's see here. So has anybody used other methodologies for phosphate testing? You mean other kits? I think this summer, didn't we use some paper?
Strips.
Sarah, what did you guys use?
Yeah, there's strips through Lamont. They recently came out with those, and they worked fairly well. We compared them against the kits to see how accurate that they were. But as with any kinds of strips, they're a little bit more subjective. So they're still a good, quick, and easy way to test for phosphates. You can find them on the Lamont website.
So Diana also posted that she has a Hawk spectrophotometer. Janet, could you unmute Diana so she could say something about it? Let's see, where's Diana? And Diana, you could actually unmute yourself, I think.
Okay.
Hello, everybody. Yeah, we use a Hawk spectrophotometer. We were able to be part of a group a few years ago where we were able to obtain one, but it's really great because in the water that we test in the river, there are such low levels of phosphate that it hardly ever shows up on some of the test kits. So by going to a little bit more of a sophisticated method, actually the methodology is not so hard, but the device measures those low levels, so we're able to get some results for the kids and actually see some stuff, see some data.
How much does it cost to get that?
Well, they go for several different prices. This one was a pricier model. It goes for a couple of thousand, but because it's lab quality, I mean, this is what laboratories might use. But it's great. We've been monitoring for several years, and it's both portable and usable in the lab. So it's one of those things that, you know, somebody might want to write a grant for because it really, really, really works well.
Great. I should get one.
Yes, absolutely. Everybody should have one.
Yeah.
That's right.
Kevin, would a university likely loan one of those things out?
Well, I don't know what the university does. I don't know. I don't even know what we do use in the lab. I don't think it's something we would loan because I can't even get access to it. So, all right. Well, we should now have Kristen give her presentation. I just want to introduce her. Let's see if I can do that. There she is. Okay. So Kristen Weaver is an education specialist at NASA Goddard Space Flight Center. We had originally scheduled Dorian Janney to present tonight, but she had a scheduling conflict, and Kristen stepped in at the last minute, and I really mean last minute, and that's really nice of her. She was a 6th and 8th grade teacher. She also did a research experience for teachers at NIST, and was the master teacher for GPM. So let me switch it over to, all right, what am I doing here? I'm missing. Okay, and I don't see how to stop sharing. Uh-oh. Janet?
I think it's often there you go.
Yeah, thank you.
Okay, so are you seeing that PowerPoint?
Yeah.
Yes, we're seeing your stuff now.
Okay, so I'm talking, so I work for the Global Precipitation Measurement Mission, which studies precipitation, and also for the Globe Observer Program. So precipitation is not actually a hydrology protocol. So I have some stuff about GPM, but also found a few things. Kevin already talked a little bit about some of them, but at least a little bit that I could find about satellites of slides that I already had prepared from other presentations. So you will notice that my slides are all kind of all over the place in terms of formatting because I was pulling from other presentations and didn't have the time to adjust them. But so the basic idea of GPM is, you know, normally you collect rain data for GLOBE or other things with rain gauges, but there aren't enough of them. So even those more complex weather stations are even rarer than just a simple rain gauge. So for example, you can see that upper left picture is the rain gauges around the world, but there's a lot of gaps, and any dots you see in the water are actually islands. There aren't rain gauges for the most part in the oceans. I suppose there could be some on buoys, but for the most part, we're just talking about land, and that doesn't cover the entire world. And in fact, that right picture, we have a little animation. I didn't include the animation here, but that you could actually take all the rain gauges in the world and put them in 2 basketball courts. And this is actually from a peer-reviewed paper that I have not actually read, but I've heard that it's actually been, that statistic has been put in a peer-reviewed paper. And then of course you have ground-based radar for precipitation data too, but even in the US where we have pretty good coverage, we still have gaps, and it doesn't go out very far over the ocean. So, that's still not going to work. So the truth is that the only way you can really get the complete picture is by using satellites. And so that's where NASA and GPM come in. So you'll see there the GPM satellite orbiting around, but even one satellite isn't enough. So we actually shared data. It's about 10 satellites I think it can vary a little bit depending on which ones are having, sometimes there are problems and one isn't providing data or something, but it's about 10 different satellites that provide data that then allow you to get the precipitation rates, both liquid and solid precipitation actually, which is something that's kind of new for the GPM satellite. So I have to remember what I have next. Oh, so these are the instruments that we've got. So I guess, my other point with that was that, so we really are talking about precipitation quantity. We're not, GPM doesn't measure anything about the quality of the water quality in any way. So that's not what this satellite is measuring. So the two instruments that we have on GPM, we have a microwave imager that gets kind of this flat image that is our precipitation totals. And then we have a precipitation radar, 2 different bands that can get us that 3-dimensional picture. So we can actually see the structure of storm clouds. And that allows us to get some really interesting data about storms. So this is Typhoon Hagupit. And you can see those pink areas, very heavy precipitation. This is out over the ocean, so you wouldn't have this data except from a satellite. But then it also allows us to see where in the storm cloud we have liquid precipitation versus solid precipitation. You can see that melting layer very clearly in the image there. So that blue to purple scale is the frozen precipitation, and the kind of green to yellow to pink is the solid precipitation. So you can, you really get a sense of what these storms look like inside the storms. And so here's just a still image kind of pointing out some of those things. This was an East Coast snowstorm from, I think it was in March a couple years ago, but you can see over land we've got frozen, but over the ocean it's actually liquid precipitation at the surface, but the top of the storm is frozen. So, we can get some really interesting information from the GPM satellite. And so when we take all of this data, this is actually near real-time data that I pulled earlier today. So this is the last week of data. There's a couple hours delay, but I pulled it, I don't know, 5 o'clock this evening. And so it probably is the last data they have, maybe from noon or thereabouts. But this is near, and you can get this on this link. It always updates to the most recent data. And this is just a neat thing to show students and have them look for patterns in the data. And how, how do they see the storms moving? Where is it liquid versus solid? We have longer ranges of data, so you can see, when there's monsoons or things like that in different parts of the world. So it's just a very useful data set, but also a very beautiful data set, I think. So then I tried to look a little bit, since, like I said, GPM is not hydrosphere, but there are satellites that at least are going to look a little bit at some of the GLOBE Hydrosphere protocols. So the first one that I had is salinity. Now my office mate at Goddard actually studies sea surface salinity, and he's still using this Aquarius data, although unfortunately the SACD satellite that had the Aquarius instrument failed last year, so it is no longer collecting new data. But I have actually asked him in the past, what size of water body can you get this kind of salinity data from? And it is, for the most part, larger water bodies. I'm not sure that he had a particular number that he could give me, but it is not going to be a river. Maybe one of the Great Lakes you could try, but it also has a lot of trouble near the coastline. So this is going to be big picture sort of thing, but it could be something that if you are near, I guess if you're in Ohio, all of you or most of you, that you're not doing salinity, but this is kind of one of the big picture things you could do. And they do actually have this kind of nice interactive website and some nice videos and things too about Aquarius, even though unfortunately the satellite is no longer functioning. They lost contact with it a while ago. So then there's also temperature, which again, I think is going to generally have some of the same problems, is that you're not going to be able to compare it's not going to be completely comparable that you go out and take your thermometer and put it in a body of water. But again, you can talk to kids about the big picture. And I think I actually had this. This is actually the animation you can see. So you can talk to them about the big picture and why it matters what the temperature of a water body is, whether that's the ocean or a smaller water body, in terms of the aquatic, how the aquatic life is affected and all that sort of thing. So, so then talking about other types of water quality, one thing that is going to have an impact on water quality is going to be, flooding and inundation of land. That's going to get, runoff and various sorts of things. And so this is from a website, flood.umd.edu, where a researcher who's at the University of Maryland and also at Goddard actually takes precipitation data and looks at flood predictions. And it's actually a reasonably easy, it's not too bad to use. And so if this is something that you're looking at your hydrology site, for example, you could go to this website and look for, maybe if you know about a particular event that has caused flooding at your site or near your site, you could actually go to this website, and I think I have another example, come on, of, you could actually pull up rainfall, and then so instantaneous over that particular day in May of last year, the 3-day accumulation, and then the detection of flood intensity. So this is something that if you've got some kind of event, you can go to this website and actually find your location and look at what data they have and whether their prediction in this model matched what you actually observed on the ground. Ocean color. So again, this is going to be something over larger surfaces, but phytoplankton, not really a GLOBE protocol, I suppose, precisely, but a measure of water, of what's in the water. And there are satellites that you can look at that, and the algal blooms that Kevin was talking about earlier. I think it depends on the resolution, how small a water body you're going to be able to get that information, but you can at least get the big picture from satellites. And so there's some chlorophyll concentration data. You can see kind of the cycles over time. And there is a new mission that will be launched, I think it's 2020 or 2021, that's specifically looking at oceans and ocean color. So I stuck that on there just to make you aware of that. I did actually find, so the Earth Observatory is a great website if you don't know about it. I did actually find this article looking at using satellites to monitor lake quality, and I didn't really have enough time to read in detail to see, what size this lake was, but it looks like they are using Landsat images. And so you can see, they have the true color on the left that's going to show, what it would actually look in visible spectrum. The false color, so that the red is going to be the vegetation, and kind of that teal color is going to be more of the paved surfaces or impervious surfaces. But they actually are trying to make a substitute for the Secchi disk, that, looking at pixel level water quality. So, like I said, I didn't really get a chance to read the article, but the link is there, was on the previous slide. I can send these to Kevin and others if you want them, or send the link later. And then actually, another thing that you can see from satellites is sometimes sediment. So this is after a tsunami that inundated this river. You can see upper left is before anything happened, an older picture. Then there was a tsunami. You can actually see some of the inundated areas and some of the sediment making the river kind of that greenish color. And then about a year later, that there's still some areas that are actually, it changed the coastline of this particular, at the mouth of this particular river. And the link to that site is there. And these are false color images. So the red is vegetation. And then I think they wanted me to say a few examples of educator resources. We do have our precipitation education website. We've got lots of different resources related to water cycle and the more about how the satellite works and all sorts of things like that. So just to point that out to you. Earth Observatory is really an excellent resource. They've always got fascinating articles and really amazing images. And then if you're looking for the global type data, this NASA Earth Observations website has good global maps of lots of different variables. They have a comparison tool, but I think there are some issues with the Java of it, so they're upgrading that. I'm not sure when that new one will come out. But if you're looking for fairly simple big picture images, this is another good source. And I think that's all I had. So trying to, like, even came in under 9 o'clock.
Well, that was amazing, Kristen. Lots of good stuff there. And I'm glad it was recorded so I can go back and watch it.
Well, that was the really quick version. Like that was, yeah, you know, at this point I could probably go on for hours just about GPM. So,
well, you know, and the link to water quality, GPM, of course, like I said earlier, was the rainfall. I have my rain gauge here, which is a kind of a problem because it's raining outside right now. And I have it inside. But, you know, that linking precipitation, having kids taking the precipitation observations, linking it to the water quality makes a lot of sense. And precipitation is a fairly easy observation as long as you can put it somewhere, the rain gauge somewhere where it won't be stolen or something like that.
right. Well, and I do think some of those, yeah, if you have the data about the rain events and then you connect it to the data about transparency or other things, I think kids will see the connections. Just GPM doesn't tell us how good our water is. It just tells us how much is raining out of the sky.
Yes. Janet wanted me to remind everyone that the webinars will be on the GLOBE Mission Earth YouTube channel. And I don't know, Janet, if you could put that link in the box, that would be helpful. Do we have any questions for Kristen? And Melody for that matter. And Laura, if anybody has any questions about how she was working with her kids. So do the dramatic pause, you know.
Hey, so Kevin, would you say then that everything that we do for Student Watershed Watch, it can be assumed that that is following GLOBE protocols, therefore we can enter that all into GLOBE for hydrology?
Uh-oh, I missed something of your question. I'm sorry. Say it again. I'm sorry.
Okay. So Student Watershed Watch on October 5th.
Right.
Can we assume that everything from Student Watershed Watch fits the GLOBE protocols enough that we can enter everything from Student Watershed Watch, not only for TMACOG's results, but also into the GLOBE database?
I think that's a really good idea to do that. One of the things with GLOBE, of course, is you can see the data once you put it in. And we didn't go over that today. But yeah, that would be something I would suggest everybody do that if you can, is enter it in the two locations.
That's what I put my water quality information. I put my water quality information that I use with TMACOG up on the GLOBE website as well.
Mm-hmm. Great. I did want to ask, there's at least one person on a phone, and I was wondering if you could say who you are. We're trying to get a sense of who everyone is on the call. Well, let's see, I think you're unmuted. There's at least one person on a phone. But we don't.
Karen is.
Oh, Karen. Okay, so you're also you're logged in through the video and the phone. Okay. All right. Thanks.
Yes. Yes.
That's great. I appreciate that. Are there any more questions for? Well, especially for Kristen. Like I said, it was last minute that she even found out that she was going to be talking tonight.
Fortunately, I have enough different presentations I could just pull from existing things and add a few slides. So
that was all really good stuff.
I have a quick comment.
Yes.
Kristen, yeah, fantastic presentation. The animation in the beginning with the satellites going around the globe, I can't recall if you had the link to that, but that would be a fantastic engage video animation to show students, to get them excited about doing GLOBE. And the other thing is too, that for us landlocked here in the Midwest, just because your students can't collect salinity data or sea surface temperature data, if they have an interest in it, they can access that data through the GLOBE website and still do research projects based on that information and all the great links that Kristen provided as well.
Yeah, so I'll put, so the animations, almost all of them are from the Scientific Visualization Studio. So there is a GPM gallery that has all of the GPM videos that I showed, plus any number of more. There's great videos, they do really great work. So I just put that in the chat. And that has the near real-time data as well. And other storms and videos that have narration as well, if you want something a little bit more that has more explanation to it.
Great.
All right, well, I appreciate everyone coming on and all the speakers today. Our next, let's see, I know I have it. Oh, let's see. Our next webinar will be in 2 weeks. Here it is. October 12th, we'll do the same time. It seems to work. And we're going to be looking at aerosols. And David Paget from Tennessee State is going to be talking about how he engages the community that their school is in. Our teacher feature will be Diana, and she's going to talk about how her kids take the aerosol observations. And our NASA nugget will be most likely someone from NASA Langley talking about the aerosol campaign that they do with GLOBE. So I hope you can join us in 2 weeks. And thank you everyone for calling in. Good night, everybody.
Thanks, everybody.